Welcome! In this lecture we will look at what happens when there is not sufficient traction force to overcome the running resistance forces, or when a negative traction force is applied. Then we will summarize how the driver can use the traction force to control the speed of the vehicle. We start the analysis from a vehicle which is driving at constant speed at 100 km per hour, with the traction force just strong enough to balance the rolling resistance and the aerodynamic drag. What will happen if the traction force becomes zero? We again calculate the sum of the remaining forces acting on the vehicle, and that gives us the net force. Notice that the net force is now in the reverse direction, and therefore we get an acceleration of minus 0.33 meters per second square in this case, which means a deceleration. Note that the changed direction of a force vector corresponds to changing sign on the force in the equations. In the force speed diagram, our traction force is just zero. So it does not add to the vector sum of all the forces on the vehicle. And thus the net force becomes the sum of the rolling resistance and the aerodynamic resistance. The result is a decelerating vehicle. Notice that since the traction force is lower than the total driving resistance, the vehicle is decelerating. When the speed drops, the aerodynamic drag is smaller and deceleration will drop. However, the powertrain can increase deceleration by producing a negative traction force. If we now calculate the net force, it becomes even more negative. This results in an acceleration of minus 0.40 meters per second square in this case. This negative traction force can be created by losses in the powertrain or by an electric motor running as a generator. If that is not sufficient, a bigger negative force can be created by the brakes of the vehicle. They of course influence the vehicle acceleration in the same way as a negative force created by a powertrain. This active deceleration can be illustrated in the force speed diagram. Notice that the y-axis has changed and now includes negative force values. The aerodynamic resistance and rolling resistance are added to the now negative traction force, resulting in a bigger negative net force and thus even more deceleration. So, now that we have studied the forces and acceleration in several different driving situations, we can draw some general conclusions about how the speed of a vehicle is controlled. 1. The driver can only control the force from the powertrain and brakes to influence the vehicle speed. 2. By changing the traction force, the net force can be controlled, such that the vehicle reaches the desired acceleration. 3. With time, acceleration or deceleration can get the vehicle to the desired speed. We can also summarize some simple control rules. The traction force must exceed the total driving resistance in order for the vehicle to accelerate. The traction force and total driving resistance must be in balance for the vehicle to have a constant speed. And traction force must be lower than the total driving resistance in order for the vehicle to decelerate. Now you know the basics of how to determine which traction force is required when driving a vehicle, and how the driver controls the speed of the vehicle by controlling the traction force from the powertrain. There is one more important force to include, and that is the force caused by road gradient. This is analyzed in another lecture. Thank you for watching.